Okay, hello everyone, and welcome to the stream. Apologise for those who tried to join a bit earlier. We got a few technical problems with the sound, so hopefully it's now all good. If anyone wants to sort of join in the conversation, please type away in the chat, and I'll be reading the chat, and we can sort of talk about any of the topics that come up as we run through. So topic for today is all about governance and trust in open economic systems. And I think this is an extremely important topic. We're talking about economic systems that are decentralized. So new actors, new participants can come in at any time and you don't know who they are. Yeah, why should you trust them? What sort of credence should you give to a random identifier that may be totally pseudonymous, and you don't really know what you should expect. And because it's an open system, anyone can join, and that means you have to assume that at least some of these actors are malicious and potentially going to try and take advantage um, of your assets. So what what Hey, is anyone on the if anyone in the chat can just confirm you can hear me okay? Just to check that this is working. Governance and trust. Okay, someone's hearing me. That's good. So the sound at least does appear to be going through. That's good to hear. So as I was saying, we're looking at situations where you potentially don't trust any other participants on the network, at least not until you've established some kind of trust basis, which is a necessary property if a system is going to be decentralized and open. You have to accept that there will be actors who may be malicious, that you're not going to, at least initially, you're not going to trust until at least you've established some basis for trust. Um, and likewise, governance is extremely important. If you are having some kind of economic system or decision system where important decisions are going to be made, which affect different kinds of assets, then it's really important that you can govern those decisions in a secure way to make sure that those decisions get made appropriately and only with the correct participants being able to, for example, vote on a board in order to make something happen. And these are sort of inextricably interlinked. Yeah, you can't have a good governance system without trust, because otherwise these random decentralized participants can disrupt your governance. So the combination, I think, really needs to sort of work together. What kind of things might you want sort of robust governance on in a sort of open system? Well, let's say you had a fully decentralized bank. So you have an institution which allows people to deposit funds in savings accounts or current accounts, and the decentralized bank is going to be making loans out of those funds, and it's going to be therefore making credit decisions of who it's going to loan to. You might have in a bank a group which is responsible for making loan decisions, and saying yes or no to a particular loan or set of loans, or delegating an amount of capital to someone who is going to um, uh, distribute some loans to a particular set of customers. So all of those are governance decisions. They're potentially economically significant. There's banks' capital base is at risk. You want to make sure those decisions are well made, but you also want it to operate on a fully decentralized system. So that's an example of something you would need governance for. Another example for governance is if you have a smart contract that you want to be upgradable. So you may want to change the logic at some later date. Then again, you're going to want governance rules about how that smart contract logic can be updated. So you might want to say, for example, only a particular account where you've got high security, sort of a cold wallet, is able to issue the instructions to upgrade a smart contract. You don't want someone with a hot wallet being able to change the rules on a smart contract. So again, that's the kind of governance rule that you might want to put in place in order to make one of these governance systems work effectively. So when we were building Convex, one of the key thoughts was, okay, how do we build a system that allows people to implement these kind of governance rules, but that really also gives a lot of flexibility, so people can experiment and develop different kinds of governance rules. We know that the state of the art about how people want to govern economic systems is going to evolve. It's a natural thing where you're going to get a evolution in the techniques, in the governance methods, even in the authorities that you might want to put in place. So we wanted a model that was flexible, that would allow for changes in governance rules and logic and evolution in governance systems. But it also had to be very robust, and meaning that people who were trying to write logic that depends on trust could really rely on how the system works and use that for authorization of different kinds of actions without worrying too much about what can go wrong. We want this to sort of embody the best practices in trust and authorization systems. So when researching this, we got inspired by something that is used, in fact, was originally developed in the US military, I believe, by a chap called James Anderson, called the reference monitor approach. And what this was a way of defining access and control rules that was very, very flexible. So it seemed to have the properties we want. So yeah, so a question from chat: can banking governance decisions be programmed so that if a threshold is met, the contract gets executed, thus limiting human interactions? Yes, exactly. That's a good example of a custom rule. Yeah, something happens automatically when something gets triggered, or it's conditional upon some kind of threshold, and you want the users to be able to define these thresholds. Yeah, what is the threshold at which certain things become possible or impossible? In fact, in the demo, I'm going to show a couple of examples of thresholds that you can actually code in using the Trust Monitor system. But really, think about it as any governance rule you can think of, you want to be able to encode. You want to be able to express some logic which implements that governance rule and does so in a robust way. And back to the topic of the reference monitor model, what that gives you is this concept that every time an action is requested, anytime someone tries to do something, there are three things that you have to consider. And you can use these three things to define your trust logic. The first thing is the subject. Who is the person that is attempting to perform an action? Yeah. So the subject is the person who's active, they're making a request, they're trying to access a resource, they're trying to update a record, whatever it is, there's always going to be someone that is making an action. And in the reference monitor approach, you have to have a way of identifying who is doing it. Yeah. If you don't know who's doing it, you've got no way of making a judgment on whether you should trust them or not. So the subject is absolutely essential. The second thing that you need in the reference monitor model is the idea of an action. So what is the action that the person is trying to do? And you can think of different ways of encoding, giving actions names. So you need to define some kind of schema, if you like, for what the different actions are. But an action might be, for example, update smart contract. Yeah. So that could be a type of action you want to do. which would have a high level of security, whereas other actions like read the current balance of my own account, would be relatively low level action. You can't really do much damage with that kind of action. Yeah. So the action is the second part that's really important in the reference monitor model. And the third part is the object. So what is the thing which is being acted on? Yeah. And that's going to depend on the action to some extent. Different actions may, refer to different kinds of objects. But for example, if you wanted to update a smart contract, well, the object would be the smart contract itself that you're trying to update. If you are trying to burn an asset, then the object would be the asset that you're trying to burn. If you're trying to create a new decentralized identity, well, that the object might be the decentralized identity that you're trying to create or update. So the object is usually an identifier of the thing that you're trying to act on. Now we think about objects very generally. Yeah, so an object certainly in Convex could be a set of items or a list of items that you're trying to act on at the same time. So particularly when you're talking about a transaction that might affect multiple things at once. But it's really up to the person defining the action and the object, depending on the particular kind of rule that you're trying to implement. So we have the subject, we have the action, and the object. And the way that the model works is for any subject, action, and an object, you have a monitor, a trust monitor, and you ask it, I've got this subject, they're trying to perform this action, and they're trying to perform the action on this object. Yes or no? Do you allow this particular action to proceed? And the trust monitor just has to answer true or false. If it's true, okay to proceed. If it's false, then the action is forbidden, and you should not allow the action to proceed. So that's basically the pattern. Now, the beautiful thing about this pattern is it's kind of universal. Anything you can think of, there's always going to be a subject, an action, and an object. So you can always define a trust monitor to check those things for pretty much anything you want to do. So we realized that, okay, it then made sense to turn this into a abstract interface. And by this I mean a way of interacting with trust monitors that is standardized. You can think of it kind of like an ERC20 token, where the ERC20 standard defines an interface for talking to fungible tokens in the Ethereum ecosystem. The trust monitor standard in Convex is a similar thing that refers to how do you talk to trust monitors. Yeah, and it's actually pretty simple. All you have is a check trusted command that takes a subject, an action, and an object, and returns whether it's permissible or not. But it is an abstract interface so that you can plug in any kind of trust monitor logic that you want. So, question of CBDCs: could you set a maximum limit of coins in an account? Yes, you could. There's multiple ways of doing that. So you could within the coin, the currency itself, you could say, okay, there's a maximum amount, a quantity that can be held by a single account, and if that gets exceeded, you just fail the transaction. Yeah. So that's one way of doing it that wouldn't need a trust monitor. But you could also configure it so, okay, whenever a quantity of coins is transferred, the CBDC calls a trust monitor and says, are you allowed to transfer this amount of currency into this account, for example? And the trust monitor could answer yes or no based on whether that transfer would take it above the limit or not. So you could define a trust monitor as a pluggable check. Now, why would you want to do that? It's actually a good example. If you decide at some future date that you want to change the limit on an account or a set of accounts, you just change the trust monitor. You can update that logic. So you wouldn't actually need to change the currency token itself. Yeah, you just switch the trust monitor or upgrade the trust monitor, and you can put in new account limits. Yeah, so it's a way of isolating the trust logic from the asset logic. The currency token implementation can be separate from the rules that you apply to that token. So a question from R in chat. So is there a trust monitor as a callable actor in the Convex library? Many trust monitors. There's many different examples of trust monitors in the standard Convex library. So I'll go through and demo a few of these, but that's exactly right. It's a callable actor. You can create these as actors and you can have them callable, and you can then use them as you wish, and you can plug and play different trust monitors into different systems. Is a trust monitor a bit like a zero knowledge proof? It's kind of a bit like it in the sense that it is answering a question that you want to know if someone knows the answer to, if they're allowed. So it's rather than proving you know something, it's proving that someone is authorized to perform a particular action. So it's a little bit similar in the sense that it's kind of like a binary function. Yeah, the thing you're proving is your right to access rather than your knowledge of something. Now it's different from a zero knowledge proof in that, you know, you're not proving knowledge, you're proving access. But it's conceptually a bit similar. It's also public, by the way. Trust monitors are public. So two reasons they're public. One, you want people to be able to test against them. Yeah, like, am I qualified to do X? You want people to be able to query and test against a trust monitor. So if I'm not authorized, I ought to be able to ask the trust monitor and say, am I not authorized, and get a false. Yeah, so I know my status, if you like, against any trust monitor. So they are public in that sense, because they're designed, and they're public because they're designed for use on chain, on a public network, for open economic systems. So by design, they're sort of open code, open data, obviously not open access, yeah, which is why they're a governance tool. Yeah, you want to use them for security and access control. So they are public in that sense. Whereas a zero knowledge proof, I mean, the reason you're doing a zero knowledge proof is presumably because you don't want to reveal the specific knowledge that that you're proving you have. But yeah, there are analogies, I guess. But it's more of a access control thing than a knowledge proof. So hopefully that all makes sense. Really good questions. There are a lot of links, yeah, between the trust monitors and the different things that you might want to do in an open economic system. And certainly the way I think about it is, look, if you have a question about should someone be allowed to do X when you're designing a smart contract or an actor on Convex, and you don't think the answer is completely fixed for all time, it might evolve, it might change, you should probably be thinking about a trust monitor that you can plug in and that you can define separately and potentially update and upgrade as your governance rules evolve. So it should be like a sort of default tool that people reach for when they run into these kind of questions of authorization, access control, or governance decision rights. And Obviously, because it's a standard, if everyone uses the same standard, that helps with reusability. It helps with composability, and there's nothing in Convex that says you have to use trust monitors, but I do think they're a very powerful standard, and they and can be very useful. So if there aren't any other questions, I'll just drop into a quick demo and like show some of what you can do with these trust monitors. So let me just switch the screen here. So what I have here is a standard Convex REPL. So as before, if I type any commands into the bottom here, they get executed, and I see the result of any command I execute immediately. It's getting executed on a test network with 5 peers at the moment. The other thing to be aware of is, I've got a few accounts available here. I'm currently using account number 12. A question from chat. A user can create one of these and then everyone can see it, which means the logic is auditable. Exactly. That's exactly right. You want trust monitors to be auditable because they are your rules for access control. Yeah. So if you're saying my smart contract upgrade process is secure, you want people to be able to examine that trust monitor and say, okay, what precisely is this trust monitor going to do in different situations? Another question: are they closely linked to questions on rights held on an SSID? And by SSID, I'm assuming self-sovereign identity. That is a brilliant question. And actually, an SSID on Convex, a DID, is a trust monitor. Yeah. So you can use your DID as a trust monitor. So you can say, for this particular access right, I would like this identity to be able to have access, or this set of identities to have access. So we do make these things work together. So any DID, decentralized identifier on Convex, works as a trust monitor, and that DID can specify which accounts are authorized to act on its behalf, and then it works as a trust monitor that basically checks the authorization for those accounts. So you might as an individual, you might have one DID, but you might have 10 different accounts that you use for different purposes. You've got a hot wallet, a cold wallet, a business account, etc. So you might have 10 accounts. So your DID can authorize those 10 accounts, or maybe 5 of those accounts. Maybe you don't want your hot wallet to be authorized. And then that DID acts as a trust monitor, which checks against those accounts, whether it's one of those accounts performing the action or not. So great question. Yeah, exactly. There's a close link between identity and trust monitors. Let me just do a quick example just to show how easy some of these things are. I'm just going to import a couple of libraries. So first of all, I'm importing the Convex Trust library. This has generic utilities around trust and governance, so it's a pretty useful library. I'm importing that. I'm importing convex.asset because we're going to do a bit with assets later. So that's one of the fundamental libraries that lets us work with digital assets. And I'm importing this new library. Now it's not yet in the sandbox. It's in the development branch, but it's not yet in the sandbox. It will be soon. But this is the convex.trust monitors library, which has some cool little utility functions for trust monitors, which I'm going to demo and sort of show what you can do with these. What else? Just so we can do some stuff with digital assets, I'm just importing the USD digital currency, and I'm also importing Chorus, which is the DEX. So that's just setup code. You don't have to do it, but it's helpful just to have these aliases to refer to these particular libraries and accounts as we work with this. So just clear that. Okay, so let's build a trust monitor. So the simplest kind of trust monitor that you might want to build is a trust monitor that just allows certain subjects. Yeah. So you might want to say, okay, only myself is going to be allowed to do things. Yeah. So we have this trust monitor. I'm using the trust monitor library, and I'm going to build and there's a utility here called permit subjects. What permit subjects is going to do is it's going to take one or more subjects and say, I want a trust monitor that is only going to allow those subjects to do something. Yeah. Now my account is 12, so I'm doing permit subjects 12, and that's it. That is a trust monitor. And it may be hard to believe, but it's literally just a small data structure. 36 is the monitor, the trust monitor implementation actor, and the this set here is just a convex set, and it's got one entry, which is the account 12, and that whole thing is what 12 bytes or something. So the trust monitors are very, very small, which is great because it means you can plug them into different assets. You can use them all over the place. You don't have to worry about significant memory confunction. They're extremely lightweight objects and be reused very easily. But that's it. That is a trust monitor. If I just want to define, let's define it. Let's call it peeps. And we're just going to use that code again. So permit subject 12. So we just defined it peeps to be that trust monitor. It's just a local variable defined now. To use a trust monitor, we have to ask the trust monitor, do you trust this subject, this action, and this object? Yeah. So this is the trust library, and the function is trusted with a question mark. It's a Boolean function. And I'm going to say, first of all, you say, what is the trust monitor I want to use, which is peeps. And I want to say, okay, does this trust monitor trust account number 12? So that's the subject of the request, and it returns true, which is good. It trusts me as the account number 12, or rather, it trusts account number 12 that they should be authorized. Because it's just permitting subject, it's a very simple trust monitor. It doesn't care about action. Yeah. So if I give it a random name for an action, and I give it a random value as an object, it doesn't care. It's going to still say true because I'm still trusted. I'm account number 12. I'm allowed to have any action or object I want. However, if I change that 12 to a different account, let's say account number 66, it returns false. Yeah. So in fact, anything other than account number 12, give me account number 13, is going to be false. Doesn't matter what, if I take away the action and the object, it's also going to return the false. So this trust monitor, its only job, it's got one job and it does it well, is to say, is the subject account number 12? And that's it. That's probably the simplest trust monitor you might want to use, but it turns out this is very useful. Yeah. So if I wanted to create a trust monitor with a set of, let's get the code again. If I wanted to allow 12, 13, and 14, so three different accounts to have access, I can do that. And you just have a slightly different trust monitor, which shows that the set of accounts allowed is 12, 13, and 14. So if I wanted to then, allow more people into my smart contract, I just change the trust monitor to have, more people listed as permissible subjects. So hopefully people are seeing the screen. I get a comment, can't see any code on the screen. I don't know if that's too small. Try and resize it slightly. Yeah, it is showing on YouTube. Sorry, I can't help you with that one right now. Okay, so that's sort of the simple trust monitor. That's just testing the subject. Um, Now let's say I want to do something more on actions. Yeah. Okay. Yeah. So some people can see the stream, some people can't. Sorry, I don't know what's going on there. Let's say you wanted to do actions. So let's say I want to allow an action of saying hello, greeting someone. So let's create a new trust monitor. Let's call it greetable, and we're going to saying in this case, let's say you want to implement some arbitrary logic. Yeah, but let's do it with some custom logic to see the particular thing that someone might want to be doing. Again, we use a monitor. We say rule. Now, rule is the most powerful piece of logic you can use, because you can basically define anything you want within this rule. And to make a rule is actually a bit of functional programming. You have to find a function, and the function is going to take 3 arguments: subject, an action, and an object. So it's going to get 3 parameters. And within the rule, I can write literally any logic I want. I can call other smart contracts. I can check for ownership of assets. I could query other actors. Any logic I want can go in here, and it's totally safe because the entire trust monitor gets sandboxed. So the code isn't allowed to have any side effects. It's not allowed to do anything with any assets. So it's safe for users of this trust monitor. They can't this can't do anything bad within this context. And let's say, okay, I want the action to be, so A is going to be the action. SAO is subject, action, object. I want the action to be greet, and that's my Boolean function, which is going to check this trust monitor. And you see I get a slightly more complicated trust monitor. So its implementation is 37, it's a rule, and then it's just stored the compiled function within the trust monitor. So it's a bit bigger, but it's got more sophisticated logic here. And if I want to do, okay, so again, I'm going to call the trusted function. I'm going to do greetable is my monitor, and my account is 12, and I'm just going to see if it trusts me. And in this case, it doesn't trust me. Why not? Because I didn't provide an action, and it's only going to say true if the action is greet. Yeah. So in order to pass this trust monitor, you have to provide an action of an action here has to be, and it doesn't matter what the object is. Yeah, it's just checking the action in this case. So that's going to be true. So anyone is allowed to greet and say hello. They're not allowed to do anything else. That's the logic which is expressed within this trust monitor. So it doesn't matter who it is. Yeah, account number 77 can also greet. So this is a good trust monitor. Yeah, if you want anyone to be able to create an account for free in your bank and make deposits, you could provide this kind of trust monitor with checking for create account, and you're saying, okay, right now it's open, anyone can create an account. In the future, you might change the trust monitor and say, okay, only people who have signed a certain agreement get to create an account. But at least you can start off with it being open access. Anyone can do it, and then refine the logic as you build your business model, or as you specify tighter controls for certain kinds of accounts or this kind of thing. How can we use this for multi-sig wallet is the question. So for multi-sig wallet, what you would need to do is collect signatures from everyone who needs to sign. So you would actually need something a little bit more sophisticated than just a single trust monitor, because a trust monitor is going to check one subject. Yeah. So what you could do is you could create an actor with a trust monitor that says, these are the people allowed to sign. And then the trust monitor checks. A good example would be this permit subjects. Yeah, I'm putting 12, 13, and 14. I could use that trust monitor to say, okay, these are the people who are allowed to sign, and then I could create an actor that says, first of all, it checks the trust monitor. Is this subject allowed to sign? Yes or no? And then it says, okay, I will allow an action to take place as long as at least 2 out of those 3 have signed. So the actor can enforce that logic. So that's how you would do multi-sig with a trust monitor. You'd have a trust monitor saying who are the allowed signers, and then possibly a separate trust monitor saying, given that the required numbers of signatures have been collected, proceed to do whatever it is requires a multi-sig action. Yeah. So that's probably how you would want to set up that kind of model. And remember, these subjects, they don't need to be users. These can be actors themselves. Yeah. So you could have a governance actor, or a DAO, for example, could be one or more of these subjects. So if a DAO had to vote in order to sign on a multi-sig contract, then that's fine. Yeah, the DAO can have its own access control rules, but then it's allowed that only that DAO would be allowed to sign under its own account to complete some multi-sig contract. So that's a good question. That's how you do multi-sig. So the next thing I just wanted to show is, okay, we've created this one that allows a certain set of subjects, so 12, 13, 14. We've also created a trust monitor that says, okay, I'm going to allow this action. Let's say you want a trust monitor that's going to check both of those conditions. Yeah, so not only do you want to control who the subjects are, but also what actions they can produce. So it's a much stricter trust monitor. So fortunately, you've got this beautiful system where you can combine trust monitors. Yeah, and this is where the composable abstraction gets very, very powerful. So what I'm going to do is I'm going to define a trust monitor called friends. And I'm going to use the monitor library, but I'm going to do all. So all is a special function that builds a trust monitor that enforces multiple conditions, and all of those conditions must be true. So I'm going to require, first of all, that they're peeps. That's the trust monitor, which was the people that I was allowing. And second, I'm going to require greetable. So this trust monitor is going to require both that they're on the list of people and that they're performing the action greet. Hopefully that works. Okay, so slightly more sophisticated trust monitor. But now if I use the trusted function, and I'm going to do friends. So this is account 77 trying to greet. Now this would have worked with a greetable function alone. We know that returned true, but now it returns false. So account 77 is not allowed to greet. However, account 13, I think they were on the list, that returns true. But account 13 cannot destroy the universe, even though they're authorized as one of the allowable subjects. That's going to be false. Yeah. So what we've done there, again, it's one line of code. We've combined 2 different trust monitors that enforce different parts of the logic that we want to have in our governance system. And the beauty of this trust monitor system is you can do this with any logic. Yeah, any logic you want to compose or build into different things, you can express that logic, and you can build this into your governance rules. One more example, I think, is just slightly more sophisticated one. let's say let's say I want to have a trust monitor which checks whether I uh, um, okay, example. Let's say I want a trust monitor that's going to check whether I own some assets. So I'm going to, first of all, I'm going to buy some USD from Taurus. So I imported Taurus earlier. I bought 100 US dollars. So that's 10,000 cents is 100 US dollars. Um, and what I'm going to do is I'm going to say, um, uh, you know, uh, let's call it money, and this is Mon. So again, it's a trust monitor, and it's the ownership trust monitor. And I'm going to say someone's got money as long as they've got at least 50 US dollars. Um, I think that works. Okay. So if I go trusted, money, um, and myself, so my current address, should be 12, do it like that, is true. So I have more than 50 US dollars. But if I ask about another account, let's say account number 70, which I don't think has any US dollars, um, it doesn't even exist, so that doesn't help. Let's say account number 26. Account number 26 doesn't have any US dollars. So you can use this ownership trust monitor to check whether someone um, has either a certain balance of a fungible token, or you can also say, does someone own an NFT, or does someone have a governance token that allows them to access a certain decision rule? So a great example, could this control things like voting in a DAO? Absolutely. This is what it's designed for, really. Yeah, I mean, checking the account, someone's US dollar balance, might make sense for, some financial institution, but, it probably doesn't make much sense from a governance perspective. But ownership of a governance token or absolutely would. Yeah. So you must own at least one share in the DAO in order to be able to have a vote in the AGM. That kind of rule you could express using this kind of system. Um, so um, that's the idea. Yeah. So you can create this particular implementation checks for ownership of an asset. You can also check for ownership of an NFT using the same owns function. So again, this is how things start to compose in Convex. You've got the universal asset model, lets you express any asset, and you've got the trust monitor model, which lets you express any governance rule. You can compose them together and say this is a trust monitor which checks for ownership of any arbitrary asset that you're interested in testing. So DAO voting is a cool example where you can use this. Let's just do a very quick final demo. If you wanted to use this in a smart contract, if you wanted to use a trust monitor to secure a smart contract, let's just show how you'd do that. Well, first of all, you define. I'm just going to clear. Let's assume we're coding a smart contract now. We're going to create a monitor for a please request. And we're going to first of all say mon permit subjects, and we're going to, let's say, allow account number 12. Yeah. So that's my monitor. And let's say I want to define a smart contract function. Um, so I'm going to say callable function, and it's called please, and it's going to have no arguments, so it's going to be relatively simple. And what we're going to do is we're going to check our trust monitor. So we're going to do trusted, the please monitor, and we're going to check the caller. So whoever the caller of this smart contract is going to get checked. The action they're doing is please, and the let's say they're asking for $1, so USD 100 cents. So that's the check that we're doing against this trust monitor. So someone's saying, please can I have $1, is the sort of the concept behind the smart contract. And you're checking this monitor to say, can they have $1 or not? And you're passing the subject. So the subject, when you're in a smart contract, in an actor, is almost always going to be caller. The caller of this function is your subject, because that's the person requesting access. The action is whatever you define, but in this case we've said it's please. And the US and the object in this case, we're talking about $1. So that's going to be the object that's passed in every case. Now, if that is true, we've said they're trusted, they're allowed to say, please, can I have $1? We're going to transfer them $1. We're going to do transfer to the caller. So we've just checked the subject is allowed. So they're allowed to receive the $1. So they're going to be the people who receive it. They're going to get USD $1. Now, that's the positive branch of the if. If it fails, well, we're just going to throw them an error. We're going to say, okay, it's going to fail because of trust. No $1 for you, with some exclamation marks just to make it very, very clear. I think that's the right amount of brackets. What have I done wrong? I keep doing this, so it needs to be a defen because I'm defining a function, not a variable. So it's defen callable. Okay, so that's worked. So I am in fact account number 12, so I'm permitted. So if I go call, well, I'm calling myself here, which is a bit silly. If I call myself and I say please, that works. Yeah, it sent $1 to myself, which is kind of not very useful. So let's have a different account. I think this is account number 13 or something. So so that's my main smart contract account. Here's account number 13. If I do from here, I'm going to go call account number 12 and say, please. And it says, and it's failed. Yeah, it said no $1 for you. And that's exactly the security we want. Yeah, unless someone's authorized by the trust monitor, we want to reject the request and fail the transaction, in fact. Yeah, so that's the result of calling from a account number 13. However, let's say I decide I now want to be generous. I'll just go back up, and I'm going to change this please monitor, and I'm going to say, okay, I'm now allowing account number 13. So I've maybe relaxed my rules. Maybe 14 can happen as well. We don't. So that's updated the please monitor, which is going to be the please monitor which is used within this smart contract. So if I try it now, that succeeded. I've been given $1 by the trust monitor, and well, let's just double check that. If I do import currency.usd, and if I import convex asset, and if I do asset balance USD, yeah, so I've now got $1 from this smart contract. So that's the idea. It's a very simple example, but that's the idea of how you want to use trust monitors within a smart contract, within an actor implementation. You want to set up a monitor. You want to use that monitor within the source code that is doing the access control check, and you want to do that access control check before you do any action which might potentially be a risk or an untrusted access. And that is effectively enough to have a full trust monitor based authorization system for your smart contract. So again, it's just a few lines of code and you can have some quite sophisticated and upgradable trust logic implemented in the system. So a question from chat: is this like two-factor authentication? Yes, it can be. I mean, your trust monitor can check multiple factors. Yeah. So one factor might be, for example, well, you've signed, yeah. So you've automatically, by being a caller, you must have signed the transaction which is making the call. So you've automatically got one factor of a digital signature on absolutely every Convex transaction. Yeah, so that's one factor. But you can have a second factor, which is someone on this particular list, a membership list, for example, which is a second factor of the authorization. Notice that's authorization rather than authentication. Yeah, so it's important to distinguish because 2FA is normally applied at the client side. Yeah, when you're signing onto your phone or you're signing onto your wallet, you would have 2FA typically at that point. Yeah, to authenticate that you are the person who's meant to have access to this account. The trust monitor sort of happens a little bit later because it's happened after you've already authenticated against your account. Yeah, so you could have two-factor authentication to sign the transaction, and then you could have two-factor authorization within a trust monitor that check whether that account is able to perform a specific action. So there is a lot of flexibility in how you make these things work. So can you do a trust monitor where everyone can interact with a contract except an account that might be suspicious? Absolutely, absolutely. So so a good example, let's just code it now. Def allowed. So we're going to do a monitor rule, and so we're just going to use the arbitrary rule. It's the easiest way to just put together some logic like this. And the rule is not equals account number 13 subject. Yeah, I think that's right. So we're saying anyone except account 13 can use this facility. If I go trusted myself on caller, I'm address, which is going to be 12. Oh, so I need to put allowed. So it's the trust monitor is the first argument, and the subject and the action and the object is the second. So I'm allowed, but if account number 13 comes along, but account 13, they're not allowed. But account number 60, I guess, would be allowed. So that's like an exclusion rule. Yeah, you can have a set of people that you want to exclude from the trust monitor. The one thing I would be very cautious, although you can do it, I would be extremely cautious about that kind of trust monitor. In fact, probably I would, flag it as a red flag in any security audit, because it's very easy for people to create new accounts that aren't on a blacklist. Yeah, if you've got a blacklist that excludes people, people can always create new accounts. So it's much better to find a rule for why you should trust someone rather than trying to exclude people who you don't trust, because the number of people that you don't trust is probably infinite. Yeah, and that's an extendable list. So while you can do that, it's definitely not recommended. And it's probably exploitable because the person you're trying to exclude can always create a new account and or can borrow someone else's account or something like that. So you're probably not going to exclude a determined attacker with that kind of rule on its own. The only case where I think that really makes sense or might make sense is if you've got something like a smart contract or an actor which is misbehaving. and you specifically want to stop that actor from doing certain things, because it had some bug in the past, and you just want to exclude it. And because the actor's immutable, there's no, you're not worried about another actor. It's always going to be the same. It's always going to be the same address, and it can't go and relocate itself to a different address, or there's no facility for it to do that. So you could use an exclusion for a particular actor, perhaps. So that's the only case I can think of where that might be a useful facility. But if you need to exclude something, you're probably doing something wrong on average. So, and hopefully that's been a good demo that sort of showed that you really can pretty much define these trust actors, and you can get them to implement any rules you want. We do have like a little library of different types of trust monitors that implement different kinds of logic. So you shouldn't have to code most of these by scratch. Yeah. So this kind of mon rule is like, if we haven't written it, then you can write it this way if you want. But normally there's going to be something like permit actions, going to permit hello and goodbye. Bye, for example. I mean, that's pre-built logic for you, so I don't have to write any code to create a trust monitor that normally would do these things. So, question: is this novel to Convex? So, to my knowledge, this is the first system that is like this. Yeah, where we've got a full reference monitor authorization model implemented as an abstraction so that you can plug and play any kind of logic you want, designed specifically for decentralized systems. So I believe it's novel to Convex. I certainly haven't seen anything like it anywhere else. I believe there are some precedents of the reference monitor model being used often in operating systems. So I believe it's a requirement for the trusted computer evaluation criteria in the US. If you want to get a security level of, I think, B3 or above, it's mandatory that you have a reference monitor model in place, because it's a pretty well proven system. But I think this is the first implementation to my knowledge, on a decentralized platform, and that's one of the reasons why we put in it at the start, because we want this to be a standard that lets people build much more powerful economic systems. Now, could you do that on other smart contract systems? I mean, possibly. I mean, I think Convex has some facilities that makes it very easy to do, because we have the on-chain compiler, so you can express arbitrary rules and logic. We have a very powerful language model which lets us create things like functional rules, custom rules, rules as code as data. All of these kind of Lisp capabilities make it quite attractive to do it on Convex. We also have very powerful data structures. So if you notice that some of these trust monitors, which is a good example, Friends was a good example. So the Friends trust monitor, this is quite a complex data structure already. Yeah, it's nested at several levels. It's got some custom rule specifiers. It's got a function with nested code inside. It's got a set. It's got some vectors, and these are all a big nested data structure. Now, Convex is an extremely powerful engine for nested recursive data structures of this kind of nature. So being able to actually express this kind of complex trust monitor compactly and efficiently in a data structure is definitely one of Convex's superpowers. So this really helps with the composability and the sort of implementation of these trust monitors. So there's and also global state. So global state is critical, yeah, because a trust monitor really, if you think about it, is an actor, yeah. So you need to be able to call it and have a smart contract call to an arbitrary trust monitor somewhere in the global state. Now, if you had to do a cross-chain or a cross-shard transaction to verify against a trust monitor, you would, in many systems, you'd have a problem. Yeah, because you wouldn't be able to do that within the scope of an atomic transaction. So again, that's something that Convex enables that isn't possible on some other systems. That depends on having a fully Turing complete engine, and it depends on having a global state in order to be able to implement that. So yeah, it's well suited to Convex, and we've got the facilities to enable this that wouldn't be possible on a lot of other technologies. Okay, so hopefully that's been a good tour of what you can do with trust monitors. There is a sort of evolving library of trust monitors. So anyone who's interested in the sort of the coding behind this, feel free to drop by the Convex Discord. I can give you some pointers to the code that we're developing, and there's a lot of room for innovation in this space. Yeah, if you've got ideas about trust monitors or governance and how we can build better governance rules for open economic systems, then there's a lot of opportunity to create some really smart code and some smart logic which can be used more broadly across the ecosystem there. So please drop by the Discord to chat about that. There is also a Convex architecture document. Let me just show that because it is a useful resource for people who want to dive into some of the sort of the magic within Convex. We have let me just get this open 1 second. We have the design repository. Let me just flip back to this. We have the design repository, which has all of these useful documents related to various different aspects of Convex. We have this CAD 22, which is about trust monitors, and this really says the details about how trust monitors work, how you interact with them, how they're intended to be used. So you can see it talks about subject, action, and object. So again, if you're interested in the details and the actual specifications of how these works, drop in by the Convex design repo, and we can if you want to contribute as well, there's plenty of good design thinking to be done to sort of evolve these specifications. So again, open invite for anyone in the community to get involved with these. So I think that's all I have for now, but as always, continue the conversation on Discord, and hope to see you all again soon.